You mean?
I go to basic reading. Maybe.
Well, better than, it could be worse. You could be going to Disneyland again, or Disney World again. Alrighty. So, what is a probability distribution? That is a chart that has probabilities on it. Somebody stole the dadgum. You gotta be kidding me. Really? Okay.
So this surprises you.
A little dipwad in here today, I guess. Doing it again. Go steal one from next door. Guess I'll have to start bringing it home. If I ever catch the little person that's doing this, I will make sure he or she, and I know it's a he, I will make sure that he not only fails this class, I will make sure that he at least gets expelled from taking a test. And any of you know who it is, I will make sure you're anonymous. Binomial distribution is consistent of the number of events on the left and the probability on the right. That is a binomial distribution. So if I say there is a couple having 3 children, what is the possibility of having boys versus girls? We got boy, 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 girl, boy, 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 girl, and then girl, 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 boy, girl, 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 boy. You're supposed to do two more. Boy, girl, girl. Thank you. And girl, boy, boy. All right. There's your. We did that sample space. One of the first things we did when we did probability, and I told you to learn that chart. Now, what is the probability of having a boy or girl? 0.5, right? Okay. Now that's an assumption. Assume 1/2 probability for a boy or a girl. Now sometimes that will be changed in the problem. Sometimes it'll say probability of having a girl is 0.52, or the probability of having a boy is 0.47, or something like that. And that does make a difference. Now, what is the probability of having, let's say, girls? Okay? So, what choices do we have? 0 girls, 1 girl, 2 girls, or what? 3 girls. Now, we all know that 0 girls means what? Boy, boy, boy. And 3 girls mean girl, girl, girls. Girl, girl, girl. So, the binomial distribution for boy, boy, boy would be 0.5 to the 3rd power. And probability of a girl, all girls, would be 0.5 to the what? 3rd power. When somebody take 0.5 and raise it to the 3rd power, tell me what you get. Well, 5 to the 3rd power is be 0.125, right? Because 5 to the 3rd power is 125. So, 0.125 and 0.125. Everybody good? All right, now we got to figure the other two. 1 girl. Well, let's go ahead and find our 1 girl. Let's take our handy dandy yellow highlighter. And that's 1 girl. And 1 girl. And 1 girl. Is that it? So that's 3. But to do 1 girl, we've got to do each one of these probabilities. So that's going to be 0.5 to the 2nd power. That's 2 boys. Times 0.5 to the 1st power. And how many of those do we have? 3, Hubert. That's right, class. So there's 3 events. So somebody take 0.5, raise it to the 2nd power. That would be what? 0.25 times 0.5 is 0.125 times 3 is what? 0.375. Now, the good thing about this is that all your numbers are going to come out the same, because 0.5 is the opposite of the complement of 0.5 in this problem. So what would this one be? 2 girls. Well, that would be 0.5 raised to the 2nd power, because you have 2 girls and then 1 boy. And that's the same thing. Now, what can you tell me about the right side of our binomial distribution? What can you tell me about it? record because I was asking you. You don't want to answer. All of them, all your probabilities are between 0 and what? And what happens if you was to add all those up? What would you get? You would get 1. So a binomial distribution, you have to test the right side to see if all are between 0 and what? 1. And if the summation of the right side, summation of p of x, is equal to what? They say in the book, you have to look in 5.2, somewhere in there, it'll say 1.00 or 1.001, something like that. Now, so your probability distribution for this would be, finished product would be 0, 1, 2, 3, and then 0.125. I don't know why this thing's writing awful today. 0.375, 0.375, and 0.125. That looks awful. Sorry. And that would be it. Now, if your probability is 0.5, then you don't have a problem. Where does the problem come in? It's when they change the probability. So let's say we did the same problem, and we want to make a chart out for the probability of girls. There. Probability of girls. I just have to write like a second grader. Probability of girls, and that means 0 girls, 1 girl, 2 girls, and 3 girls. And over here is basically the probability of that event happening. But in this problem, there is a medicine that's being used that changes the probability. Probability of a boy is equal to 0.52, or wrong correction, 0.42. That's all they give you, and they want you to make a probability distribution. So take your calculators out and go ahead and fill out that chart. First of all, what's the complement of 0.42? All right, so the probability of not boy, or probability of a girl, is equal to 0.58. Now you've got what you need to do your probability distribution. And if you can't do it, just mark it down as being a failure. Yeah, last night there was no good movies on. I ended up having to watch The Deer Hunter for about the 50th time. That was no fun. So to start you off, what would 0 girls be? Boy, 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 right? So that would be point what raised to the third power? 0.42 raised to the third power. So now give me that number. .74088.741. Now, if we can do 3 girls that easy, or 0 girls that easy, what else can we do that easy? 3 girls. And what would that be?
I'm so sorry.
0.58. I'm supposed to go into hysterics right now, aren't I?
I was trying to put my calculator and my Pandora down on.
Let's see, what am I supposed to say? You're a failure. All right, what's 0.58 raised to the 3rd power? 0.195. All right, now y'all do the middle two. You can see my sign over here.
I was trying to put the calculator down.
I'm surprised mine hasn't went off. One girl means that there's 1 girl and 2 what? So that would be 0.42 raised to the 2nd power times 0.58 raised to the 1st power, and all that times 3, because there's 3 of those events that could happen. No sneezing in class. What is all that times 3? What does that come up to be? Okay, y'all doing it by hand or what? How much? 0.307. Two girls would be what? 0.58 to the 2nd power unit. That's right, class. And 1 boy, 0.42 to the 1st power, times 3, because there's 3 events there happening. And what does that come out to be? Right quick, add all those up. See what you get. Something's wrong, man.
It's the first one that's not, it's supposed to be 0.07.
I appreciate y'all setting me up for failure. Y'all suck. All right, so what's this one supposed to be? Okay. So add all those up. What do you get? That one, that one, that one, and that one. What do you get? So that's how you check yourself to make sure you have to set somebody up for failure, like y'all did me. So your probability distribution for this guy would be probability of girls and probability of that event happening, and 0, 1, 2, 3, 0.07, 0.307, 0.424, and 0.195. And that is probability distribution. See, that's not too bad. But try to have a class do a probability distribution and not show an example first. People won't know what to do. Because you can't go by what they give you in the book, because you get confused. So now let's look at a problem that they're going to give you for homework. Because this is the hardest section out of chapter 5. Do what you got to do by hand. The rest of it's calculator. me find a test question that I'll give you. There it is. They already done it for you. Now, oh my gosh, we got to find the mean and the standard deviation. How do you do that? Well, the mean and standard deviation, you remember in the frequency distribution you had that big old huge intimidating formula with n times p of x times, or n times the summation of p times x, quantity squared, or something like that, minus p of x squared, or something, p of p times x, or whatever. It is a big old nasty looking thing. Over n times n minus 1, remember that? Well, you're going to do the same thing on this one, except it's going to be a whole lot easier. To find the mean of a standard of a binomial distribution, real simple. Where's my duplicate there? There we go. The mean of a probability distribution is equal to the summation of x times p of x over should be n, or the summation of x. Okay? And they should give you that as soon as you hit help me solve this. There it is. Well, they don't, there it is. No, they don't give it to you. They just, well, you got to get summation of p of x. Okay, find the summation of p of x. I had x in there, sorry. There we go. So that's, add all these up to check to see if it's a, it is x times p of x. They're checking it to see if it's a binomial distribution. So check it to see if it's a binomial distribution. Usually they give you a formula. See, they usually give the formula right here. I'll give you an example. They didn't do it. There we go. Well, it's still not giving you the... No. Okay, so I'm going to have to give it to you. In your book, there is a list of formulas. Let me go ahead and get it for you, because I was expecting it to come up on the handy-dandy problem, but it didn't. It's in blue, usually. Okay, green. There they are. And that is the mean, the summation of x times p of x. I'm sorry. Let me just go ahead and give you the three that I'm going to use, because they give you 5 or 4. I'm going to use 5.1, 5.3, and 5.4. 5.1, 5.3, and 5.4. So 5.1 is the mean, which is x times p of x. And 5.3, what is that called? The variance, which we don't use very much. And then you take the square root of the variance, that gives you the what? Standard deviation. So let's take this problem that we were doing, wherever it went. There we go. Let's take this problem right here, and I'm going to put it in this Excel spreadsheet. And we'll do it on the Excel spreadsheet, so it won't take up all the board. And make it big so y'all can see it. And I'll put it right here. There we go. Everybody good? All I did was copy and paste it, so you should be okay with that. Alright, so the first thing we're going to do is find x times what? X times p of x. I'll do the first one for you, 0. Take that and multiply that times, isn't it amazing how I did that in my head? Y'all just don't respond to anything, do you? There it is. And then what do you do to find the mean? Add those what? Add those up. And that is your mean. Now that's pretty simple. Now how do you find the variance or the standard deviation? Well, I really don't care about the variance, but the questions in the book may ask you to find the variance, or the homework may ask you to find the variance. So we're going to find the variance. So we go to our handy dandy formula. What do we need that we don't have in the variance and standard deviation formula? X squared. So that means we got to make a column called what? Nothing gets by, y'all. Nothing. I'll do the first one for you. There you go. Now, we got to take x squared, and what we got to do with it? P of x, get that summation, and then subtract what? U squared. So let's do that. X squared times P of x. Now I'm going to separate it a little bit so you won't get confused. X squared times, X squared times P of x. So equals x squared times P of x. Now don't pick the wrong one. Make sure I don't. And get that sum. And now my variance is going to be equal to this minus what? This what? Squared. I think you're smart, don't you, Mr. Brown? There it is. And of course, to find the standard deviation, raise that to the what? To the 0.5 power. And you feel good about yourself. Now, if I've got the mean and standard deviation, what can I make? Or the normal distribution curve. I know that's what you meant. Okay? So let's do that. Let's just go down here, and our mean is equal to this guy. And what's 2 to the right? Take the mean and add what? Standard deviation, Hubert. That's right, class. And this plus standard deviation. And then what do we do to the left? Subtract minus standard deviation. And equals this minus standard deviation. And there's your curve. So of course now you can say anything between negative 0.34 and 3.1 is normal. And this is what you were given. This is the probability distribution. Binomial, probability, whatever. That's your distribution right there.
Message coming in on secured channel.
Aprende?
Priority one
So,
message
you
coming
need to
in
be
on
able
secured
to
channel.
make a probability distribution, and then you should be able to find the mean and standard deviation. So what was our mean on that one? Our mean is 1.382. 1.38. And we feel good about ourselves. Oh, look over there. It's asking for the variance or the standard deviation. And the standard deviation is 0.86. Is it unusual for a family of 3 children to have only girls? Well, what is only girls? 0.09. What would this be in money? 0.098. What would that be in money? That's right, class. Y'all telling me y'all don't know that that's 10 cents? Yes? No? Maybe? Vanna, does that look like 10 cents to you? Thank you, Vanna. Okay, now what has that got to do with the question, Hubert? Well, what is this? What is this money-wise? 5 cents, which is a what? A nickel. All right? So less than a nickel would be unusual. What is this? It's a dime. So is it normal? Yes. Because if it's less than a nickel, it would be what? It would be unusual. Let me show you that because some of y'all, I don't think you got it because y'all are not talking, so I guess I need to explain it. But that could be either way in this class because y'all don't talk. So, empirical rule. Empirical rule says that 95% falls within 2 what? So 95% is normal. Now, if 95% is normal, what are these 2 guys out here? Huh? Unusual. Somebody tell me what the percentage is of unusual. 5%. Y'all just jump on in, you know, whenever y'all get the answer in your head, just blurt it on out. So that's 2.5 cents here, right? And 2.5 cents here, right? So, if you have something less than 5% or 5 cents, it would be what? Huh? It would be unusual. Anything more than 5 cents would dump it in where? Normal. You understand? Just shout it on out, you know. Whenever you get the answer in your head, just shout it on out. Y'all settle down. I'm not going to give you one like this on the test because that take you 15 minutes to do that one. I was going to try to find you one that'd be a good test question. Nope. I'll give Vanna that one. Let's see. No. Look at there, Mexicans. Talking about Mexicans, that's racist. Look at there. How many Mexicans they put on the jury? That's racist. Let's see. Okay. Try that one. First of all, check it because some of these homework problems, they're not a binomial distribution, so you need to check the right-hand side before you even start. All right, I'll blow it up a little bit for you. Vanna, I'm giving you the day off. Vanna's the one stealing my styluses in the morning. I know that's what it is. There you go. They already have done the binomial distribution for you, so you don't have to do that much. The directions say find the mean and standard deviation, so chances are they're going to ask you about if something's unusual or not. What time's class over? Just checking. See if y'all tell me the truth.
Priority 1 message coming in on secured channel.
Go ahead and do the roll. Keep the bureaucrats happy. Today's March the Bailey,
Yes.
Bolt, Clayton, Cowart, Stutzky's here, Escobar, Farr, Freeman, Hammett, Harris, Harvey, Hayes,
Here.
Johnson,
Here.
Mullins,
Here.
Murray's here, Newton, Poor, Perdesi. Does anybody know Mr. Perdesi? Sorta. Is he sit? Where does he sit when he's here? All right. If you see him, tell him I need to see him. Okay. Light skinned. I think I know who it is. Okay. Robinson. Oh, let me check. See, all my Robinsons are here. 2 of them are here. I guess Mahogany's not here. Scarborough's here. Schuler, Simpkins, and Dennis. I don't see Dennis. Smallwood. I don't see my other Vaughn either. Smallwood's not here, and Anna Vaughn's not here. Williams. No Williams. Wood. No Wood. I want to check. Let's see. Few attendance for this class. I want to make sure I hadn't missed any. They say I missed a day of attendance. Wednesday. Did I not take attendance Wednesday? Huh? I got a what? Okay. Well, I better just take attendance and y'all tell me if y'all were here or not, and I'll take it for the next couple of days, and that way I'll get everybody. They don't like it when we do that. They have a fit. We have people actually paid to look at attendance. They actually get paid salary to watch attendance. Yeah. They just make notes. If there any time that you have everybody here, you'll get an email to make sure you check your attendance. So if you have a good class and everybody shows up, that's not good. Tri-County Tech is not. All right. This is Wednesday. Y'all just be honest, okay? I don't care if you don't care or not. No big deal. Bailey, were you here? Okay. Bolt? Okay. Clayton? She ain't here, so I'm going to say no, but she needs to tell me maybe tomorrow. Coward? She wasn't here. Okay. Dutchke, were you here? You ain't going to lie to me, are you? Escobar, were you here? Farr? Freeman? You wasn't? Okay. Thank you for being honest. Hammett? No. Harris? You were here. Harvey? You was not? Okay. Hayes? Loser. Johnson? You were here. Mullins? Okay. Murray, were you here? Okay. Newton? You wasn't? Everybody laid out Wednesday. Poor? You were here. Perdesi, was he here? Don't know. Was Robinson's here? Okay, 2 of y'all was here. I don't know about Mahogany. I'll ask her tomorrow. Scarborough, were you here? Schuler? Simpkins? Don't know if Dennis was here. Smallwood? Don't know. Mr. Vaughn, I know you were here. You're always here. Williams? Don't know. And Wood? Don't know. I need to go over this tomorrow, Wednesday again. So y'all remind me to do that. I don't know if I'll be able to change it or not, but I'll try. Because the bureaucrats, they go over it and they'll seal it so you can't go back in and change it. This is such a crime wave, attendance is such a big crime thing now. Glad our federal government is really hunkering down on people trying to get over on their attendance in college, but our borders in north and south are open as. Glad our federal government is really prioritizing what's important. Did y'all catch any sarcasm there? A little bit, maybe. federal government don't get us killed is what I'm worried about. Anyway, here we go. So we're going to take this guy, and of course I'm going to put it on a spreadsheet. And I'm going to go to my handy dandy spreadsheet, and I'm just going to go make another one. And I'm going to paste it. And there it is. Let's check it to make sure that it is a binomial distribution. Yep, it is. So I'm going to go ahead and find x times p of x. And that's going to equal this times this. Most of you should be able to handle the first couple of ones. And summation of that, I get 2.68. What'd y'all get? Y'all feel good about yourself. So x squared, I gotta tell y'all about Tractor Supply yesterday. X squared and copy that down and take x squared times what? Times p of x. This is where you got to watch it. Be careful, because I'll do it in a heartbeat. Times p of x, which is right there, and copy it down and slide it over so y'all can see it. Thank you. Now y'all know why I have Bannon do this, because I suck at it. There we go. And now we take our handy dandy summation and there's that. And oh, that's the mean. Sorry. Is that the mean? Yeah. That's the mean. I need to put it. And the variance is going to be equal to this guy minus this guy squared. And there's my variance. My standard deviation is going to be equal to this guy raised to the what? 0.5. And now we just take our handy dandy mean, put it in the middle, equals this plus this and this plus this. And on the left hand side, what do? Y'all be surprised on how many people forget. I had a brain bubble there for a second. Excuse me. I know y'all don't have those very often, but I do. So what is normal? 0.06 to 5.3, right? So now we go back to our handy dandy problem. Done. And our mean, sorry, let me go back. Our mean is 2.68. Oh, got something wrong. Let me check, make sure I rounded right. What? Oh, 2.7. Sorry, I suck. Standard deviation is 1.3. And they didn't ask for that gummit. Okay, they didn't ask for. Well, let me ask you. What would you say if I asked you if 6 was a normal or unusual event? 6, that's out here. Normal or unusual? Unusual, Hubert. That's right, class, because normal would be up to what? 5.3. Okay? So, with your binomial distribution, make sure you can do the following in 5.2. Now, let y'all go. Make sure you can create a binomial distribution. 5.2. 5.2. Make sure you can create a binomial distribution. Make sure you can find the mean. Make sure you can find the standard deviation. And make sure you can interpret, I don't know how to spell it, but make sure you can interpret if it's a normal event or if it's an unusual event. Now, Tractor Supply.